So hey everyone, welcome back to the channel. In this video we will be solving the problem find all four sum numbers. So let's read the problem statement out. So we are given an array of integers and another number k. Find all unique quadruple from the given array that sums up to k. Basically a quadruple means a set of four elements, and also note that all the quadruples which return should be internally sorted. That is, for any quadruple q1, q2, q3, q4, the following should be the order. So let's say if my n is going to be 5 and k is going to be 3, means we have to find a quadruple whose sum is going to be equal to 3. Okay, so here the quadruple whose sum is going to be 3 is going to be 0, 0, 1 and 2. So this is going to be my answer. Okay. Similarly, there can be more than one quadruple, so you have to return all of them. So for example, here k equal to 23, so these all quadruples sum up to 23. So we need to find all the quadruples. And also in the problem, we have to find the unique quadruples only. For example, let's say if some quadruple is repeating, so we don't need to take that quadruple into account. Okay. So let's discuss this problem in more detail. So let's say my array is this and we need to find all the quadruples whose sum is going to be 23. So how can we do this problem? The basic brute force approach in order to solve this problem can be, we can run a for loop. Okay. The for loop will be running from 0 to n minus 3, right? So our for loop will be running from 10 to 4. Now inside that for loop, what we can do? We can have a j loop which will be running from basically I plus 1 to n minus 2. So j will be running from I plus 1 to n minus 2, and then again we will be having a k loop which will be running from nothing but j plus 1 to n minus 1, and inside that we can have a L loop which will be running from k plus 1 to n, right? And in this way what we can do, we can add up array of I plus array of j plus array of k plus array of L, and we will check if it is equal to our k or not. If that is equal, what we can do, we can store this quadruple, let's say, inside a vector, and we can store that inside a map or a set. So let's say we store that inside a map. So map will store the vector containing all these four elements, and we will proceed forward. So in that way, if this vector containing all the unique elements are already present in our map, we will not be pushing that into our map again, and otherwise we can push that into our map. But before doing any operations, do remember that the elements can be repeating inside that, so it's better to sort this array, right? So first approach should be sorting the array, then only start any operations, because if you don't sort the array, it might happen that you end up having like similar elements. Okay, so that is the one point. Or otherwise what you can do, every time you need to sort this array, so that will increase your complexity. So overall this complexity is going to be order of n to the power 4, but we need to optimize this. So let's say my array is like this: 10, 2, 3, 4, 5, 7 and 8, and we need to find for k equal to 23. Now first of all, we will be sorting the array. Why? Because we need to return the quadruple in a sorted manner. We will be using a extension of two pointer technique. Basically in two pointer technique we are concerned with two elements, but here we need to find four elements, so we will be using a four pointer technique. Okay, and it's basically extension over two pointer technique. Let's see how can we do that. So for that, first of all, we will be having a sorted array. Okay, so we have sorted our array. Now we will be having a I. Now at every point of time we will be needing at least four elements, so our I will be running from 0 till n minus 3. So let's say this is 0, 1, 2, 3, 4, 5 and 6. So our array length was 7. So I will be running till this point. Now we will be having a j which will be starting from I plus 1, or let's say we name it as start, and we will be having a left pointer which will be starting from start plus 1, and let's say this is going to be my right pointer. So let's sum up all of them. So 2 plus 3 is going to be 5, plus 4 is 9, plus 10 is 19. So now if you observe what happens, our total sum is less than the required sum, right? So in this case we will be moving the left pointer first. Okay. So see, for the first case what happens, I will be remaining at here, start will be at here, and right will be at here. We will be now moving the left pointer only. Okay. Now this time 2 plus 3 is going to be 5, 5 plus 5 is 10, 10 plus 10 is going to be 20. 20 is again less than 23. We will again move the left pointer. Why we are moving the left pointer? Because you know our array is sorted. So when we move the left pointer, our approximation to get closer to a point which is equal to sum will increase. ठीक है? So ऑब्वियसली 4 से बड़ा है 5, 5 से बड़ा है 7. सो अगर हम लोग लेफ्ट पॉइंटर को राइट की तरफ मूव करेंगे, सो प्रोबेबिलिटी बढ़ जाएगा ना कि हमारा सम जल्दी मिल सकता है हमें, है ना? तो दैट्स वाई वी आर मूविंग आवर लेफ्ट पॉइंटर. Now here 2 plus 3 is going to be 5, 5 plus 7 is going to be 12, plus 10 is going to be 22. So 22 is again less than 23. So again left move the left pointer till the point where left is less than n minus 1. ठीक है? So this was the n minus 1th index. So left will be moving till n less than n minus 1th index. ठीक है? So now 2 plus 3 is going to be 5, 5 plus 8 is going to be 13, plus 10 is going to be 23. Now our sum is equal to be 23. So let's push all these indexes into our answer. So basically we need the elements. So we will be pushing 2, 3, 8 and 10 into our answer. Or you can check whether this vector exists in our map or not. Then only we will be pushing that into our answer, because we need unique combinations. Okay. Now next time what happens? Your I will be shifted to 1 point forward. Okay. So I will be here. Now our start will start from here. ठीक है. Left will be start plus 1, right will be pointing to here. So 3 plus 4 is going to be 7, 7 plus 5 is 12, 12 plus 10 is going to be 22. So here 22 is going to be less than 23. So we will move our left. So left will come here at the next iteration. So 3 plus 4 is going to be 7, 7 plus 7 is going to be 14. 14 plus 10 is going to be 24. Now this time if you observe, 24 is greater than my required sum. So now in order to reduce our required sum, what we can do? We can move our right pointer to one step back, because we know 8 is less than 10. So it will reduce our sum. Okay. So that's why in this case we will move our right pointer. So now our sum is going to be 8 plus 7 is 15. 15 plus 4 is going to be 19, plus 3 is going to be 22. Now 22 is again less than 23. Now when we move our left pointer, we can't move, because in that case left will be equal to right. We need to move only the point where left is less than right. Okay. So we will be moving our left pointer till the point where left is going to be lesser than right. Okay. Now in the next iteration, I will move one step forward and we will do the same thing. Okay. So I will be here, left will be here, or start will be here. Okay. Left will be here and right will be here. Okay. So 4 plus 5 is going to be 9, plus 7 is 16, plus 10 is going to be 26. So that is greater. So move our right to one step backward. Okay. So in this way you can solve the problem, and in the end you will be getting your answer. And it at every point of time before pushing that into your answer, just check if it exists in our map or not. And if it doesn't exist, push that vector into your answer and mark them as like present in our map. So I hope you have understood the implementation. In this way, basically, let's say this is my array. Okay. We will be having 4 pointers. Okay. I start, left and right. Right will be the pointer which will be pointing to last element in every iteration. Left will be nothing but start plus 1. In every iteration it will start from start plus 1. Start will be starting from I plus 1 and I will be the pointer which will be running from 0 to n minus 3. Why? Because अगर i हमारा यहाँ पे होगा, ठीक है, तभी हम यहाँ से स्टार्ट ले सकते हैं, यहाँ से लेफ्ट ले सकते हैं और यहाँ से राइट ले सकते हैं, है ना? Because at every point of time we need at least 4 elements. So that's why this. So I hope you have understood, and let's discuss the implementation. So see, first of all we have taken an answer vector in order to return our answer, okay? And then we will be sorting our array first because we need to uh, return the elements in a sorted manner. Now n is going to be the array dot size, I is going to be 0 initially, okay? And we have taken a map of vector of int comma int in order to check whether my current set is present in our map or not. Then only we will be pushing that into our answer. So while I is less than n minus 3, we will be starting our start from I plus 1 as I told you. While start is less than n minus 2, okay, we will be having a left which is equal to start plus 1. Right is going to be n minus 1, and we will check while left is less than right. We can sum of all the elements, basically array of I, array of start, array of left and array of right, and we will compare with k. If it is equal to k, there is a possibility that it can be my answer, okay? So when that is going to be equal, what we will be doing? We will be checking whether that is present in our map or not. If it is present, we will not be doing anything, but if it is not present, we will be pushing that into our answer and marking them as present in our map, okay? And when both of them are equal, we need to find for rest of the elements. In that case, we will be incrementing our left and decrementing our right, okay? So anytime if that is the case, when it is equal, we will be incrementing our left and decrementing our right. Otherwise, if our sum is less than k, means we need to increase our sum. For that, move our left. So left plus plus, and in the case where it is going to be greater than k, we will be moving our right in order to reduce the sum. And after every iteration, like after this while loop finishes, we will be incrementing our start, okay? And we will be, after that, when this loop finishes, we will be incrementing our I, and in the end we can return our answer, okay? So I hope you have understood the problem. The space complexity is going to be, we are basically using a map, so it will be taking the number of unique quadruples found in the map, okay? So I hope you have understood the problem. If you have any doubts, write it down in the comments. Like this video if you have understood, subscribe to my channel, and thanks for watching.